today on Monday, April 17th, 2017, we are doing lesson 5.5, and your learning goal is to be able to explain to somebody else how cubic centimeters are related to milliliters. Okay? Now, these are two different kinds of units, aren't they? Cubic centimeters, what is a cubic centimeter? Itai?
Cubic centimeter is like a cube that each of its three dimensions are 1 centimeter in length.
You got it. It's a unit cube that's 1 centimeter in each dimension, right? It's 1 centimeter long, 1 centimeter wide, and 1 centimeter tall. And we've been using cubic centimeters as the units to find what? Volume, or how much space a 3D object takes up. Good. So today we're going to figure out how that little cube is related to a milliliter. Okay. We've talked about milliliters before in science. Do you guys remember when we used syringes like this to measure milliliters of water? Yeah? So we're going to figure out how this relates to one of these cubes, basically. Okay? All right, let's first talk about the problem of the day. As we know, volume is how many unit cubes you can pack into a solid figure, right? Do you guys remember building those nets and then putting in the unit cubes and counting them to find out what the volume was? So we also know that volume means how much space a three-dimensional object or a 3D object takes up, right? Capacity is another word that describes that same thing. I want you guys to write this blue definition down. Capacity means how much you could fill a solid figure. Okay? So volume, therefore, describes the capacity or how much a 3D object can hold. Okay? So finding the volume, for instance, of this box would help me figure out how many cubic centimeters or how much water or how much I could fill this box with. Does that make sense? The capacity is how much a room can fill, how much something can fill. Have you guys heard of like the maximum capacity of a room? That means based on fire safety, that's the maximum number of people that can fit in the room. Not like how much can we pack tightly, but how much it's safe to have, how many number of people it's safe to have in the room. Does that make sense? Okay, so capacity means how much you can fill something. So the capacity of this syringe, for instance, is 50 milliliters, because the most amount of water I could put into here, if I pull it all the way to the end, is how much? 50 milliliters. The maximum capacity of this syringe is 50 milliliters. Does that make sense? So volume, because it describes how much space something takes up, also describes how much you can fill into it. Does that make sense? Mm-hmm. Very good. So another word for volume sometimes you might hear is capacity. Okay? We know that we can fill a box with unit cubes to find out how much, what the volume is. Yes? Okay, so let's go ahead and try that. So by filling this box with unit cubes, finding the volume, and then also finding how much water can fit, we can see that the relationship between a cubic centimeter and a milliliter is that they are equal. Okay? So one of these unit cubes, centimeter unit cubes, if I were to turn this into water, turn it into liquid, and use my syringe or my graduated cylinder to measure it, I would find that that's equal exactly to 1 milliliter. Okay? Okay, so if we have 5 milliliters of water, it would be filled up to the 5 mark, so you would shade up to there. And we could say at first there was 5 milliliters of water. Yes? Now if I added 1 more milliliter of water to the beaker, where would the water level go to? Alexander? 6 milliliters. Good, so then shade it in to 6. Now, if I were to drop a 1 centimeter cube in to that beaker that's filled at 6, what would happen to the water level? It would rise to what number? 7. Very good. So it would be up to 7. Does that make sense? Because we know that 1 milliliter is exactly equal to 1 cubic centimeter. So if I added 2 more milliliters of water to that last beaker, what would the line be at? 9. If I added 2 more milliliters of water. Now if I added 1 more cubic centimeter to that, what would it be at? 10. Do you see how that works? Very good. Right off the bat, we should be thinking in our head or drawing a sketch, okay? This is not the world's best 3D prism, but we need to draw a sketch. So we draw the rectangular tank. We know it's a rectangular one, so we can draw a rectangular prism. And it measures 30 centimeters. It doesn't matter which one is the length, which one's the width. This by 20 centimeters by 40 centimeters. Okay, the question is asking how many milliliters of water are in the tank when it is full, and also how many liters is that? So we want to find out how many milliliters and also how many liters. Okay, so first let's find the volume. Well, we know we can find the volume by finding the area of the base, which in this case is 30 centimeters times 20 centimeters, which is 600 square centimeters, yes?
Yeah.
Now we can multiply that by the height. If you're taking good notes, you're writing this down as I am as well. Okay, so once we have the area of the base, we can multiply that by the height, which is 40 centimeters. So the volume of this is 24,000 cubic centimeters. Yes?
Yeah.
Now, because we know that 1 cubic centimeter is equal to 1 milliliter, how many milliliters can fit in a box that has a volume of 24,000 cubic centimeters? 24,000 milliliters. Good. So your first answer to the first question is 24,000 milliliters. Okay. However, the question also asks you how many liters that is. So in order to do that, we need to use what we know about unit conversions. We know that 24,000 milliliters is equal to 24,000 times how many milliliters? 1 milliliter. Very good. Which is equal to 24,000 times how many liters? 1 milliliter is what? 1/1000th. Very good. So we write that 1/1000th of a liter. Then I can do 24,000 times 1 over 1,000, which is the same as 24,000 over 1,000. And I can divide both of those by 1,000, right? To get the answer of 24 liters.